Hey everybody, welcome back. We have reached the middle of August. School looms ever closer. I'm sure by the time you're watching this, it's already the school year. So take a moment, think back about what you were doing in the middle of August. Take a deep breath, relax. Wasn't it a great time? All right, back to reality. So we are moving on to the other side of a market. So far this year, we've been talking about consumers the whole time. Consumers and demand. Now we're going to start talking about firms and eventually talking about supply. So in a market, you've got two sides. You've got the consumers, you've got the suppliers. So now we're starting on the suppliers. So a lot of what we're going to look at in this presentation is super similar to the stuff we looked at the beginning about consumers. The graphs are going to look similar. The math is similar, all that stuff. On the consumer side, you have individuals in the market that want to reach a maximum level of utility that they can afford. So they want to get to the highest indifference curve they can, that's on their budget constraint. Firms have a similar incentive. The assumption we're making is that whatever level of output a firm wants to produce, they want to do it in the least costly way. So they want to reach a certain level of output at a minimum possible cost. So consumers are trying to maximize utility, and suppliers and producers are trying to minimize costs. So let's start taking a look at the types of graphs that we are going to be using to do this analysis. So the first part of the graph is called an isocost curve. So first I want to talk a little bit about what's on the axes and all that stuff. So on these types of graphs we're going to be looking at for suppliers. The different inputs a firm uses to produce their goods or services are what's on the axis. So, there's a jillion different types of firms out there producing all sorts of different products. They all might use different types of inputs. There are a lot of different types of inputs. Labor, meaning human beings who work in your firm. Capital, which means machinery, computers, that sort of stuff. If somebody is a farmer, they will also be using land. So their main inputs might be land, labor, capital for machines, and then maybe they also use like fertilizer and stuff like that. So they may have 4 different types of inputs. If you are an IT firm, or maybe you're a website, your inputs might be labor, human beings, servers, capital, that might be part of your capital. You might have other specialized inputs that are unique to your type of firm. In this class, we are almost always going to be looking at cases where there are only 2 inputs, labor, which we will generally put on the horizontal axis, and capital. All of the analysis and the results we're going to do, it doesn't matter what's on the axes. You could put land and labor on the axes. The names on the axes are just labels. You could substitute them out for all different ones. So the 2 input case is going to be pretty representative of any type of firm you could be talking about. You could also, this analysis also could apply if you had more than 2 inputs. So let's say you had 5 different inputs you're using. The same type of approach and the same type of math could be used to analyze that situation. It just makes the math a little bit more complicated. Well, actually a lot more complicated past the kind of math that we need to be doing in this class. So the 2 input case, may not be a perfect fit for every type of firm out there, but it's going to be pretty accurate and a good way to get the ideas of how firms choose to produce goods. Okay. So on this graph that we're looking at on the screen, labor is on the horizontal axis and capital is on the vertical. Labor might be measured in like number of hours you pay that you have employees on the clock or something like that. So point A would represent, so right here, that would represent you employ 4 hours of capital to produce that at that combination. So point A represents you employ no labor and 4 units of capital. Point C over here would be you have 6 units of labor and 1 unit of capital, and so on and so forth. So the next question is, why are these all on the same line? So they are all on the same line because all of those bundles that we just looked at all cost the same amount. That's why this is called an ISO cost curve. ISO means same and cost. So everything on this line has the same total cost. So where this line came from is I assumed that wages, so that's what you have to pay for each hour of labor, is $15. And this word rent right here, that's the word that we use for basically wages you have to pay to machines or to capital. So just so you understand why that makes sense, it might be that I'm renting the machines I use in my business. So like if I'm a farmer, I might be renting a combine, or I might have bought the combine and I'm like paying payments on it monthly, like you would a car or something like that. So whatever or if you have a server bank at your company, you might have to pay to maintain the servers. You might have to pay for replacement parts and that sort of thing. So rent is, when we talk about rent to capital, that's just the price of what you have to pay to use the machines. Just like if you want to get people to work for you, you have to pay them a wage. If you want machines to work for you, you have to pay certain costs to go along, then we call that rent. Okay, so then for a company that only uses 2 inputs, their total cost is the wage rate, W, times the number of hours of labor, and then whatever the rent is for machines times the amount of machines you have, K. So if rent is $30 and the wage rate is 15, you just plug in, so at point A, that is 0 labor and 4 capital. So okay. 4 capital and the rent is $30 an hour. And then 0 labor times 15, you get $120. If you plug in for point C with 6 units of labor and 1 unit of capital, you'll also get that the total cost is $120. So any point along this line will give you the same total cost, $120. So that is an ISO cost line for the cost $120. The slope of an ISO cost line, so this is important right here, is going to be W over R, as long as you have labor on the horizontal and capital on the vertical. So when we were talking about consumers, a lot of times we knew the rule that the slope of a budget constraint was the price of the horizontal good over the price of the vertical good. This is the version of that rule for the producer side. So the slope of an ISO cost line is always W over R. Okay. Okay, so these are 3 ISO cost lines that represent increasing costs. So the lowest ISO cost line is the one we were just looking at. It's the red line. That represents a total cost of $120. The blue cost, everything along the blue line, is $180. And the green line represents the ISO cost line for $240 total cost. This is all still assuming the wages are $15 and rent is $30. So moral of the story is, as ISO cost lines move up and out, that represents higher costs. Okay, so the other side of these graphs, just like we had budget constraints and indifference curves for consumers, we're going to have ISO cost lines and ISO quant curves for producers. So ISO quant, again, ISO means same, quant means quantity. So every combination of labor and capital along this curve produces the same level of output or quantity for the firm. So here at point A is 2 units of labor and 8 units of capital. If I use that, so if I pay for 2 hours of labor and 8 hours of machine rental, that will produce the same output for my firm as 4 hours of labor and 4 hours of capital. So, I mean, you can imagine that there are a lot of different ways to produce the same amount of goods if you're a firm. You could have a lot of people on your staff, but very few computers, or you could have a ton of computers and not very many people. All of those, there are a lot of different combinations of inputs that could produce the same amount of output. So the fact that you can produce the same amount of output by exchanging some labor for capital and vice versa implies that labor and capital are to some extent substitutable. You can substitute one for the other, and that makes a lot of common sense. If you think about like a fast food restaurant, you could have a person working the drive-through window, or you might have a system where you just like a touch screen where you put in your order and it automates your input. Or you can imagine, a lot of drive-thrus, there are two windows, one where you put in the order and one where you pick it up. You can imagine you could have a restaurant where there are people at both of those windows. You can imagine one where the first window is a touch screen where you put in your order, and the second window is a person who hands you your order. And then you can imagine, a situation where the first window is a touch screen, and then like some sort of robot dispenser gives you your order at the second window. You could potentially serve the same number of customers with all those different configurations. But what the shape of the isoquant shows, the way that it curves like this, is that, as you might imagine from our previous units, there are diminishing returns to inputs, right? So if I start here, at this point up here, this is a ton of capital and not very much labor. What that means is I can give up a lot of capital and increase labor by little. So that extra labor I picked up is, even though I only picked up like an hour of labor here, I only moved over by about 1 unit, maybe 1.5 units. I was able to keep the quantity I produced at the same level, even though I gave up a ton of capital. So here, a little bit of labor is worth a lot of capital because you are at a high level of capital. So this might be, so if you were here at Star, that might be a situation where you're using too many computers or trying to automate too much, when in fact just hiring a person to do some of that work would be more efficient. Different story down here at C. C is where you're using a ton of labor but not very much capital. So that could be a situation where you've got 10 people in the office and only one computer, and everybody has to wait to take turns to use the computer. Well, here, if you fire a bunch of those people and get a couple more computers, you can still produce the same level of output. So what that means is that it's the same idea as we've talked about diminishing returns many times, is that every time you add some input, you do increase your output level, but each additional unit of either capital or labor adds less and less and less to your total output. So again, more of an input is helpful, but the first unit of labor that you add is going to be much more, add much more to your output than the 100th unit of labor that you add. So diminishing marginal returns again. Okay. Finding the cost minimizing combination of capital and labor is going to look super familiar. These are isoquants representing increasing amounts of output. So there's a question here. Go ahead and guess which one is the lowest level of output and rank them from lowest to highest. Okay, the explanation of this is on these textbook pages, and in the next presentation we will get into how to find the optimal combination of capital and labor, meaning the cost minimizing combination of capital and labor to produce a certain level of output. It's going to look super familiar. Thanks, y'all. Bye.